Assalamualaikum warahmatullahi wabarakatuh. My name is Vicky Adania. For the next 5 minutes, I'm going to present our project called Application of Science and Technology to Create a Small Tempe Industry in Bangun Tampan, Bantul, along with our 4 colleagues, Dr. Andika, Dr. Feriawan, and our friends from Asia University, Taiwan, Moshe Rahman. Okay, let's start it. To begin with, as the introduction, so what happens, why we need to choose tempeh. Tempeh here has become the main industry in KUB Rela in Banguntapan, especially for the small, medium industries in Banguntapan. However, here the industries of tempeh here nowadays have become traditionally, let's say, processed. Let us say here, to make the beans to make the tempeh here, there are some processes, and those processes are still remaining traditional. For example, soaking the soybean seeds for almost 12 hours, boiling and waiting for the temperature as expected, and using barefoot to peel the epitome of the soybean seed and washing the seeds for several times to get the process to further. So this is very traditional. Several productive residents do not work a low standard of living with income levels, and also finding employment is difficult due to a lack of competence and education. In Banguntapan have become our background to do a community service in terms of creating a product that can be used for making tempeh industry more hygienic. So our aims here is increasing the productivity and also increasing the economic feasibility through the investment cost. Our method here, we are going to use a systematic architecture, and also we are going to apply feasibility analysis. On the left side on your project here, there's what would be the architecture that we are going to propose to the industry, tempeh, especially in Banguntapan. If you look at the product here, number one is a cover, grinder, a grinder, frame, tip plate, and so on and so on. So these are the product that we are going to propose. And feasibility analysis, we are going to include the break-even point, benefit cost ratio, payback period, return on investment. And the results here, as we try to implement the, let's say, the product here, once when we grind the beans here, what happens if you look at the last row, the last column on our first column table or figure here, we look at 2.5 millimeters is the distance. And the number of 82, there will be like 82% of the whole 100 grams that have been grinded here that can be split into two. Okay, so the results here show that when we look at this rotational speed, clearance space at the level of 386, we get the maximum point that would be 82%, 167 of the whole 100 grams here could be split into two. Meanwhile, for the, let's say, the second aims here, increasing the economic feasibility through investment cost. If you look at the initial investment, we only need 450,000 that could be spent for production house, grinded soybeans tool, gas stove, gas canister, and production support tool. But when we look at the feasibility analysis here, we look at the whole here, 24,973, and the return on investment ROI would be 88.3. Now, as our part conclusions here, indeed that the product that we propose, it could increase the productivity of the beans and also improve production investment costs. The soybean grinder test yielded an average of 78 grams of split soybeans when grinding 100 grams of soybeans at a spacing of 2.5 millimeters using a variable grinder speed ranging from 300 to 700. The economic analysis results indicate that the investment cost for implementing soybean grinding technology in the small tempeh industry is profitable with a BC ratio of 1.24. That would be more than 1. So thank you once again here. That's a very short to show that how our project here works for KUB Rela in Banguntapan. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.